Alright, this problem tells us to use the fundamental identities to get an equivalent expression using sine and cosine. Well, I noticed that this one's already in sine and this one's not in a sine or cosine. This looks a little suspicious. 1 minus sine squared theta. Well, if I think of my Pythagorean identity, sine squared alpha minus cosine squared alpha equals 1. Well, how do I get plus? Thank you. How do I get it to read 1 minus sine squared? I'll just have to subtract it. Raise your hand if you did that. This cancels, and I'm left with cosine squared alpha equals 1 minus sine squared alpha. And there is my substitution. Instead of writing 1 minus sine squared alpha, what are we going to write, class? Cosine squared alpha. Okay. Here's a hint. In more complicated math problems, when you have to do fractions, it's kind of nice to draw the fraction line in a different color so you don't get distracted, especially if you're doing fractions and fractions. Alright, I have 1 plus cotangent squared alpha. What's the Pythagorean identity? 1 tangent squared alpha equals cosecant squared alpha. So I'm going to do another substitution right here. So now I have cosecant squared alpha, right? Every time I see 1 plus cotangent squared alpha, I can write cosecant squared alpha. There it is. Do the substitution. Alright, now I'm going to change them into sine and cosines. Cosine squared alpha divided by cosecant squared alpha. I can make this one a fraction by just putting it over 1. I'm not sure if that helps. But we can definitely change that one to what? That's going to change to multiplication. And this is going to turn into, okay, pay attention now. I can leave this as cosecant squared alpha over 1, and then we can take the reciprocal, see what happens. 1 over cosecant squared alpha. They tell me to change them into sine and cosines. What is this going to become? What is it going to become? Why sine? Yeah, reciprocal identity. So your answer is cosine squared alpha times sine squared alpha. That's it. That's not the Pythagorean identity because it's a multiplication.